Greetings, Patriots. We are starting solving one-step equations. Please make sure you set up your math folder and refer to your guided notes, okay? Then take some good notes on solving equations. The objective is we will solve one-step equations given a situation or picture. Let's look at the first example. Here one is selling charity tickets or tickets at a charity event, and they're $6 each. How many tickets, there we go, does he have to sell in order to make $114? Well, if every ticket is $6 each, we know he had to sell or would have sold so many in order to make $114. I can set up my equation as 6 times the number of tickets, since that's what I'm looking for, is equal to 114. So once again, if I look at the operation, multiplication is happening. Well, what's the inverse of multiplication? It is division. So I'm going to divide by 6 on both sides in order to figure out how many tickets were purchased. And when I do that, I know I can take 114 divided by 6, and that is going to equal 19. So this tells me that 19 tickets were sold, and that's how we know that he, in order for him to make $114, he sold 19 tickets. I can always check my solution by multiplying that solution. I can go back, substitute that in my equation, and 6 times 19 is equal to 114. Does 114 equal 114? We're going to say, yes, this is true, so the solution of 19 is the correct solution. On a number line, how do I graph 19? Well, I know 19 is a positive whole number, or natural number, should I say, and it's to the right of 0, so 19 is my answer. Okay, let's go ahead and look at the following problem. Melanie works as a nanny and she's paid $14 every single hour. So in this problem, she put in 40 hours of work over 7 days. So they want to know how much did she earn in a week. Oh, so now I need to figure out the amount of money she earned. Well, I know she had to make quite a bit of money since she worked 40 hours. And I know she worked 40 hours in the week, right? So that means I would take that amount of money and divide it by 14, whatever amount of money that she earned working 40 hours. So some number divided by 14 is going to equal 40. Well, here you see that my expression or my equation includes division. Well, I'm not going to do division. I'm going to do the inverse of division in order to figure out how much money that Melanie worked. So divide by 14, what's the inverse of that? It's to multiply by 14. And what I do to one side, I do to the other side. So in order to figure out how much money was earned, I can multiply 40 times 14. And when I do that, I'm going to get the following answer, $560. So how much does she work putting in 40 hours of work? She earned $560. I can simply take that 560, divide it by 14 to see if that equals 40. And when I do that, I get 40 does equal 40. So the amount of money that was earned was $560. And where would I graph that on a number line? Well, here's 0. 560 would be really quite far, but as long as you note that that 560 is to the right of 0, that's what's important, and that was the amount earned. Okay, let's go work problem number 3. Oh, here's some of those algebra tiles like we've been using in class. So I'm going to go ahead and represent this equation as two groups of x is equal to a negative 6. So once again, I know I have to figure out what x is by itself, right? So 2 times some number equals negative 6. Well, what's the inverse of multiplication? And that is to divide. So remember how we were dividing evenly our color tiles? So if I have negative 6 color tiles, I want to know how many equals to one group of x. So again, I can divide those evenly, and I can see that x is equal to negative 3. So if I do the inverse of that, I can check 2 times negative 3. Does that equal a negative 6? And I know that a positive times a negative, remember your triangle, -6 equals -6. So therefore, -3 is a true solution because -6 does equal -6. Now, where would that -3, my solution of -3, go on the number line? Well, now it's not to the right of 0, it is to the left of 0. So -3 is to the left of 0, 3 spaces away from 0. Please make sure when you're graphing your solution on the number line that you are on the correct side of 0. Okay, let's go ahead and look at this last problem. Again, I have some number -5 that equals 7. So I like to use my inverse operations to help me figure out what I'm doing. And since I have subtracting 5, I'm not going to subtract 5. Remember, I need to make my 0 pairs by adding 5 to both sides. What I do to one side, I do to the other. And we said this over and over in class last week. So a -5 and a +5, right? That gives me 0 pairs. And z is equal to 12. So we could have solved this with pictures as well, where we had our variable of x, and we had, right, -5, so I'm putting 5 negatives. And on the other side, I had 7 positives. Yep, there it is. So how do I get rid of those 0 pairs? I got to bring in 5 negatives. And what I do to one side, I do to the other side. So you notice I'm continuously bringing those 5 positives over, because what I do to one side, I do to the other. These form 0 pairs, but notice I can't make any 0 pairs here. So therefore, z is equal to 12. So once again, can I check my solution of 12? Of course I can. 12 take away 5, does that equal 7? And I'm going to say yes, 7 equals 7. So the solution of 12 is true. Where is 12 in relation to 0? It is to the right of 0. So my final answer is a positive 12. All right, in tomorrow's class, we will be working the we do problems. Please attempt these on your own and make sure you're in our Zoom session so that we can review answers together. All right, have a great day, Patriots.